Right, we have this Euclidean geometry question in front of us, and we want to solve this Euclidean geometry question step by step. And this is the past exam question, and we proceed to solve this question. In the diagram below, two unequal circles intersect at A and B. Okay, they intersect at the points A and B. AB is produced to C such that CD is a tangent to the circle. Right, so we note that AB is produced to C such that CD is a tangent to the circle ABD at D, okay? It's a tangent at D. In other words, CD is a tangent at D. Right, F and G are points on the smaller circle such that CGF, right, let's see, CGF, right? And DBF, right? DBF are straight lines. AD and AG are drawn, right? You have AD and you have AG, and those are drawn. Prove that angle B4 equals angle D1 plus angle D2. Let's take a look at these and see what we can do here to solve this problem, right? To actually answer this question, we note a couple of things, right, that remain extremely important. First things first, we're able to see that angle B4, right, as it sits here, is equal to angle A1 plus angle D2. Right, equals angle A1 plus angle D2, like so. This is clearly the kind of theorem that the Greeks learn in mathematics. So you have this particular formation, and the exterior angle of a triangle equals the sum of the interior opposite angles, and sometimes it's even drawn this way from at grade 10, so that this angle here equals the sum of those angles there. Right, so in other words, the reason for this is that the exterior angle of triangle equals the sum of interior opposite angles. Right, next, what are we able to see? Right, we're able to note at this point that angle A1 equals the angle D1. Angle A1 equals the angle D1. Right, so angle A1 is equals to the angle D1. Why? Angle A1 equals the angle D1. This is the 10 chord theorem. 10 chord theorem. And as a consequence, then we're able to say, hence now we're able to say that the angle B4 is actually equal to, right, the angle D1 plus the angle D2. So in other words, the angle B4 is the angle D1 plus the angle D2. Why is this the case? It is the case because we're able to see that here in this equation, angle A1 equals the angle D1. Okay, and then we have solved this problem step by step. Okay, next, we proceed to look at, so in other words, we have been able to answer question 9.2.1, and we proceed to do 9.2.2. Right, so to do 9.2.2, you need to prove that A, G, C, D, right? Here is A, here is G, here is C, and here is D. So A, G, C, D is a cyclic quadrilateral, and we proceed to prove this with ease. Right, first things first, how do we prove that? Right, to prove this here, we take note of a couple of things that remain extremely important. Right, one of which is to realize that we can actually be in a position to prove that at this point, this is the quad the examiner is speaking about. Okay, let us just trace it like this. Let us just trace it this way and trace it this way. So we can prove that this angle here is equal to this angle there. And how do we then prove that this angle outside is equals to the angle inside? Okay, so there are a couple of things that remain very important. Angle, first and foremost, we can see that angle G2 is equals to angle B2. Right, we're able to see that angle G2 is equals to the angle B2. Why? These are angles in same segment. Angles in same segment. Right, so if angle G2 equals angle B2, those are angles in same segment. Right, in which case, therefore, the angle B2 equals the angle before, for example, that is what somebody is able to see here. So angle B2, right, is equal to the angle before. Why? Because these are vertically opposite angles, okay? So we can see that angle B2 equals angle before, and these are vertically opposite angles. And we spend some time to think about what this means. But we remember that in the first question, so we can be able to, we're able to see that angle G2, then it is actually equal to the angle before. Okay, we can draw the conclusion that angle G2 is equals to angle before. So yeah, therefore this is the case. Okay, because both angles are equal to the angle B2. And therefore, at this point, we know that before is equal to obviously D1 and D2. So you can say that, but angle before is equal to the angle D1 plus the angle D2. Why is this the case? Well, it has been proved in 9.2.1 above. Okay, so it has been proved there. And hence, what are we able to say? We're able to say that the angle G2 is actually equal to the angle D1 plus the angle D2. So we're able to see that this angle G2 is equal to this angle here. Right, and this is very, very important. Why is it important? Because it is able to show that the exterior angle of this chord equals the interior opposite angle. Okay, now we learn about this theorem here. This angle is equal to that angle there. Okay, right, so that's AG, AGCD is a cyclic quad. It's a cyclic quad. Why is it a cyclic quad? Because of the converse. Converse exterior angle cyclic quad. Okay, because so in other words, thus we're able to see that thus AGCD is a cyclic quad. The converse of the converse exterior angle cyclic quad property. Okay, so this is the theorem that obviously we learned, and it is the converse of this particular theorem that says the exterior angle of cyclic quad must equal the interior opposite angle. So yeah, we have been able to show that the angle G2 here is equal to the angle G1 and G2. And this means, therefore, that AGCD is a cyclic quadrilateral. And we proceed to prove 9.2.3. 9.2.3 is this one. We need to prove that DC, right? Here is D and here is C, right? So DC is equal to CF. And so, how do we prove this? Right, to prove this, we will attempt to prove that angle D1 equals angle F. Angle D1 equals angle F. Let's start by noting that the angle D1 is equal to the angle A2. Let's look at this carefully. Why is angle D1 equals to the angle A2? Right, these are angles in same segment. These are angles in same segment. So D1 equals A2, these are angles in same segment. Moreover, angle A2 is equals to angle F. Well, the angles in same segment because of this. Because of this. So this angle here is equal to this angle there. And these are angles in the same segment because we know that obviously you can, just do it this way because you're able to see the distance here and this comes down here. Because we know that AGCD is a cyclic quad. Right, so these angles are in the same, this is cyclic quad and therefore you have angles in the same segment. Okay, just take note of that. So we're able to see therefore that angle A2 is equal to angle F. Why is angle A2 equals angle F? Right, here is angle, let me just clean up a little bit for this to be very, very visible. And we note that at this point, angle A2, which is this angle there, right, is equals to angle F, which is this angle here, because these surely are angles in the same segment. Okay, because you can see this here and this there. So these are angles in same seg. In same seg. So that angle D1 is equal to angle F. D1 equals angle F. So D1 is therefore equal to angle F. Well, because both are equal to A2, these. Okay. And if D1 equals angle F, we're celebrating because this one is equal to this one here. And this means, therefore, angle side DC is equal to CF. And these are sides opposite equal angles. Side opposite equal angles. Right, so so DC is equal to CF, and these are sides opposite equal angles. Okay. And this is the answer. And we've been able to do this 9.2.3, and we have done this very successfully. All right, and we are so excited to have been able to prove this one. Yeah, so we have got to the end of this particular question, but a very, very interesting question. And this question we've just solved is the past exam question that was set at grade 12. It was set at grade 12 in June 2016, right, in June 2016. And it was a mathematics, it was in mathematics, right, mathematics paper 2 exam. Okay, and this was the question which I solved. Okay, so thanks everybody for watching and for joining us, and a very, very goodbye to you.